Hi, I'm Bob Tabor with LearnVisualStudio.net. In this video, we're going to learn more about working with collections of data. Now, in the previous video, I talked about collections as arrays with superpowers. There's a number of different types of collections in the .NET Framework class library, and I demonstrated just a handful of them. The nuanced differences between the collections are there to give you, the developer, a couple of options. So you pick the collection that best suits what you're trying to accomplish. All collections essentially do the same thing. Each collection simply holds a series of references to objects that are already in memory. So you create 1,000 new car objects and you populate their properties and you add them to a collection. The collection simply hangs on to the address of each of those car objects in memory. So at that point, you can then reference a single car object by using its index into the collection, or you can iterate through the entire collection itself, like we've seen with the for each statement. But suppose that you don't want to simply iterate through the entire collection or list of instances of car. You only want to find a subset of that list that meet a certain criteria. So you want to work with a subset of all the cars on the car lot. Say you only want to work with the BMWs, or you only want to work with those cars that are less than 3 years old. And so how do you do that? What method do you use to just work with a subset without iterating through each item in the list? Well, this is made possible through a new innovation that was relatively new, added to .NET a couple of years ago, called LINQ to Objects, LINQ. And it stands for Language Integrated Query. In this lesson, I'm going to explain the role of LINQ and then provide a few examples to get you started working with LINQ within your applications, or at the very least, see what other people are doing in their code examples with LINQ and be able to, at the very least, decipher what it is that they're trying to accomplish. All right? But if you're familiar with relational databases and querying them using structured query language, or SQL, also commonly called SQL, you'll undoubtedly be familiar with selecting data from a database like so. You can see that I have the SQL Server Management Studio, and I'm looking at a database called Acme, and it's a simple database that just has a couple of columns related to customers. So I may want to find all customers, in which case I could write a query statement that looks like this. And if you're not familiar with this is just fine. But you'll see that this is the etymology for the LINQ syntax, at least the query syntax. So I'm going to hit the execute now, and I'm looking at every single row in the database, 1,000 rows of customer data. And we can just roll through these. And this is just sample data that I cooked up. All right, but suppose I wanted to filter this list. I don't want to look at every single customer. I only want to find those who live in Illinois. So I'm going to add a where clause where state equals Illinois. And now we're only looking at 16 rows of data. You can see that each of them have a state of Illinois. Let's separate these on two different lines so we can keep track of them. Now, what if I wanted to find only those customers in Illinois with a credit limit that's greater than $19,000? So I might say where credit limit is greater than 19,000 and state is equal to Illinois, and I'll hit the execute. So that reduces our result set down from 1,000 rows now to 3 rows. And say I wanted to find one last criteria, and where the customer so they've been a customer since January 1st of 2009. All right, and that identifies 2 customers. I could also further sort these by last name, and I would just use an order by clause, last name. And now you can see the K in NAP comes before the M in Maddox. All right? And so when you think about it, working with a sequence or a set of rows that are stored in a database like we just demonstrated here, and working with a set or a sequence of objects that are stored in a collection, those are very similar concepts. You're still working with a large potential set of data, but you're filtering it down using, in this case, where clauses to sort, to filter rather, and then you can also sort the content using an order by statement in SQL. So some smart people at Microsoft ask, well, why can't we use a SQL-like syntax to query objects in a collection? And this is why they came up with LINQ. It allows developers to use a syntax that they're already familiar with, most likely, and then run queries against collections of objects. So let's do this. I'm going to set up an example here for us to look at. Okay, so wherever you're streaming this video from, or wherever you downloaded it from, you should be able to get to the code that accompanies this lesson. And so I've already downloaded and opened up for lesson number 22, this lesson, a folder that contains a before and after snapshot. In the before folder, I'm going to copy this understanding LINQ directory, and I'm going to place it into the folder on my local hard drive where Visual Studio stores its projects. Now, if you've watched the previous videos, you should be already familiar with this process. I'm going to go to my Documents directory. My particular version and edition of Visual Studio saves its projects into Visual Studio 2010 project subfolder. You'll want to copy and paste it into whatever subfolder your version and edition of Visual Studio is saving its projects into. So it'll probably be different than the one that I am, or possibly. So let's double click and open up the Understanding LINQ subfolder now that it's been copied. And I'm going to double click on the Understanding LINQ solution file, and this will open up my copy of Visual Studio. Alright, so let's take a quick moment to overview the project before we get started. I have a single class called car, and it has a number of public properties: make, model, year, sticker price, and a color that's an enumeration of type car color, which I define below it. In the module 1.vb, here I use collection initializers and object initializers to create a number of cars so that we can filter and sort a small list or a small collection of cars. Okay? So let's do this. Let's start to write some LINQ syntax that will give us a subset of this list of cars that we can work with. And so the first example, we'll just find all of the cars that are BMWs. So dim, whatever I want to call this subset, dim BMWs equals from car in my cars. Again, this is the name of the collection that we're filtering, where car.make equals BMW select car. Okay, and then what we can do is for each car, let's do this, for each my car as car in BMWs, console.writeLine and then we'll just put some details about this in the console window. So here we'll go car.make, or my car rather, my car.make, my car.model, my car.year. Okay, so let's run the example. There are 3 BMWs in our collection, and it seems like it has found all 3 of them. We can eye it up here very easily and see that that is true. So you can see, first of all, that the syntax is very similar to the structured query language, or SQL. There is a select statement. Admittedly, it's at the bottom. There is a technical reason for this that involves generating IntelliSense based on the type. So they needed to be able to change the order around just a little bit, but still that shouldn't be too much of a hindrance for those who are already familiar with the syntax. So from car and my cars, so a lot of these syntax elements are similar, and you should become familiar with them as well. So that's how I'm able to filter down a simple list based on a single where clause, where the car.make equals BMW. Let's extend this just a little bit. This time, let's use two where clauses. And it's important that you leave this second where clause that's concatenated using the AND keyword on the same line. So both where clauses need to be on the same line in order for this to work correctly. All right. Whoops. Should be my car. All right, so let's run this application again. And here we've narrowed down the list to a single item which meets both criteria. Great. All right, now that we've kind of covered some basic scenarios, let me throw a little bit of a wrinkle into to what we're doing here and show you a slightly more complex example. The reason why you'd want to do this may not become so obvious at this moment, but you may see code examples out there that use this style or this syntax, and I want you to at least be aware of what it is and what it's trying to accomplish. I don't expect you to go out and use this on your first project, but let's just follow along and see where this takes us. So say I want to find all cars that were created since 2009, but I don't want all the information about cars. I only want to pull out just a few snippets of information about a car. So I don't want to return the entire car object. Let's just say I want to create a new object on the fly that only contains 3 properties about a given car. Again, why you want to do this, let's leave that to another time. The fact that you can do this is what we want to demonstrate in this video. So let me do this. And then let's change this to all right, and let's comment that out and move that up here. All right, so let's notice a couple of things. First of all, as I hover my mouse cursor over the blue squiggly line, it says the value of anonymous type cannot be converted to understanding LINQ.car. The understanding LINQ part is the default namespace. The car is our car class in the car.vb file. So what we're attempting to do is look through each item in our new cars collection that was a filtered list of all cars on our car lot. And it says we're trying to look at each item in this car lot as if it's of data type car. But it's not a data type car. It's complaining that we're trying to convert it or cast it into a data type car, and that simply can't happen. And the reason why it can't happen is because we've created a new data type. So we started out with a car, but because we use this new with syntax, we're creating a new data type that does not have a name. It doesn't have a name, so it's anonymous. So we're basically creating a filtered list of cars, and we're filtering out the number of properties and projecting them into a new anonymous data type that we've never predefined, but now we're using. So to make this example work, all I got to do is remove the as car part, and this should run as expected. But the bigger picture here is the use of anonymous types that we can define on the fly when we dimension our new cars list. It can derive from that LINQ query that we wrote the data type that's stored in our new filtered list, and then we can utilize that. But it's not of type car anymore. It's a new data type that only contains these three values. It's anonymous, but it's still able to work with it in a strongly typed fashion. Okay? So again, confusing concept. I just want you to be aware when you see this select new with the open and closing curly braces that we're projecting into a new data type without a name, an anonymous data type, and we're able to still iterate through that new anonymous data type because although it's anonymous, it's still defined at compile time by the .NET Framework compiler for Visual Basic. All right? Okay, so let's move on from there. Let's get rid of this example. In the SQL example that we used earlier, I demonstrated how we were able to order using the order by clause. Well, we can do something similar using the link to object syntax. So dim Okay, so here again, similar syntax. The last thing we're going to do is order by the year before then we select the cars into our new ordered cars list. And you can see now they're ordered in the year that they were built. Great. All right, so this syntax that looks like Transact SQL or SQL, structure query language, is called the query syntax. But LINQ has two ways to express these types of queries. The first, obviously, being the query syntax. The other is method syntax. So let me show you how we would do something similar to what we've done earlier, but only using the method syntax. Notice I'm using a method, so mycars.where, and then we're going to pass in a lambda expression. Now this might look a little complicated. It's looking for a predicate. So essentially all we're going to do is pass in a lambda expression, function car, given a car passed in, return back all cars where the year is 2010. And then we're going to chain the where clauses, pass in another lambda expression, and here I'm just going to copy and paste this part. Tired of typing this part out. Great. Okay, so let's run it, make sure it works first. Great, it does. So we were able to essentially create this exact example here where we define two where clauses using the method syntax. So I call the where method twice. This where method returns a list, a collection, And then we further filter that collection with a second where method, and then give the final value to this collection called BMWs, and then we iterate through it. So I use this term lambda expression, and a lambda expression is basically a shortcut for a method. We needed a method that would create a filter. So the filter here is where the car.year is 2010. This little syntax here is a shortened version of a method. We could pass in a pointer to a method that we created, like down here, a little helper method, but this is just a little shortcut method syntax that performs a tiny operation, okay? That's all it is. There's more to lambda expressions, but again, I just want to demonstrate the idea that you can create the exact same queries using a different style of syntax, but it's still considered linked to objects. Here, let's do this one more time. And in my opinion, there are times when using the query syntax is easier. There are other times when using the method syntax is easier. So let's order by function car.year. And then let me just basically copy this and paste it here. All right, and run this application again. All right, so we get the ordering again. So this line of code is roughly equivalent to that line of code. Now, from the Visual Basic compiler perspective, it doesn't care. It will convert this code into this code, but they'll both work identically. There's also, as you can see, a order by descending version of this. So if you don't want it to order from earliest to latest, it'll go from latest to earliest by changing the order by to an order by descending. One more thing and then we'll wrap this up. Suppose now I have this subset of collection of cars. I want to perform some operation on my cars. So I might call a sum method. This is a different type of linked to object statement. It's an extension method that allows us to tack on functionality to the default implementation of a collection. In this case, this sum takes a lambda expression. Whatever we pass into the lambda expression, it will use that to add up all those values. So across every object in that collection, look at the sticker price and add those up, sum them together, and then let's print that to screen. And so our car lot is worth $250,000. Okay, and again, I use the term extension method. I passed in a lambda expression. These are all new and foreign concepts to you, most likely. Don't worry about them. You can typically just follow examples on the internet. You can look at the help in MSDN to kind of decipher what these are doing. Just understand that these are many methods, many functions, helper methods that we can create in a tiny line of code as opposed to defining them outside of the module or the class or whatever the case might be. Okay, and in this particular case, this extension method is tacked on, bolted onto the side of a collection. There are a number of extension methods that have been added by linked to objects, and these allow you to do cool things like, without having to iterate through every item in a collection, just say, give it the column you want summed, and it will do internally however it goes through, whether it's a looping function or whatever, we don't care, as long as it gives us the total sticker price. using this sum method, okay? All right, I've thrown a lot of new ideas at you. I don't expect you to use these. I've emphasized that over and over, so don't get stressed out if they don't make a whole lot of sense up front. The important thing is when you see these in other people's code that you can at least get some general idea of what's going on and it doesn't throw you for a loop completely, okay? So we're getting very close to the end. Hang in there. You're doing great. We'll see you in the next video. Thank you.